Question 5 asks, which of the following is an equation of the quadratic function that has a maximum value of -2 at x equals 4? So this information here, that there's a max of -2 at x equals 4, means that the vertex of our function is at the point 4, -2, and it must open downwards. So in other words, opening downwards means that therefore a, our coefficient a, is negative. So all these options here are conveniently in the form y equals a times x minus p squared plus q. So that's going to make it relatively easy for us to see where the vertex is. And looking at these options here, simply knowing that a is negative, we can cross off a few of the options. We can cross off option B and D because these have a positive 1 essentially in front of this x, in front of this squared term. So next thing we want to do is see how this vertex has shifted in our case. So if we imagine that the normal vertex of the quadratic function y equals x squared is at 0, 0, we've shifted in this case to 4, -2. So we've done a translation down by 2 units, and we've also done a translation to the right by 4 units because we've shifted over to this point. So this translation down refers to the value q, and since we've gone down, q is going to be negative, and we've gone down 2 units, so q is equal to -2. A translation left or right refers to the coefficient, or the variable p, and since we've gone to the right, p is going to be positive. We've gone to the right 4 units, so p equals 4. So plugging that in is going to give us y equals a times x minus 4 squared minus 2. And you can see that I've left this a here as a variable because we actually don't know what a is. And sorry, a, like we said earlier, is going to be negative. We don't know the value of a. But it actually doesn't really matter because looking at these options, we can see that only option E has a -4 here in the squared term and a -2 on the outside here. So E matches up with the values for P and Q that we've figured out, and therefore E is the right answer. But we can see that in E we also have this -3 for our value of A on the outside here, and it doesn't really matter what A is, but in this case we can think about what would happen to this function, and in this case we've also expanded along the y-axis by a factor of 3, but we can think of some other possible equations with different values for A that also meet the criteria given in this question. But out of the options given, answer E is the correct one.